Hi everyone, I am Dr. Mahendar, Associate Professor of Mathematics, B.V. Raj Institute of Technology, Narsapur. Today's lectures, I am going to cover the revision of linear algebra and calculus and some of the examination tips. So mainly, I am preparing this video for the keeping both fast learners and as well as the slow learners. So definitely, the fast learners will get the good score, and also as well as the slow learners also will get the how to get the pass marks for this after watching this video. Let's move to the topic. So we have the linear algebra and calculus. Total we have the 5 units. So let's move to the one by one unit what content we have. So that is LEAC, linear algebra and calculus. The unit 1, is the theory of the matrices. So mainly we have, this is the theory of matrices. So mainly we have 3 major concepts in this one. So first one is the finding rank, the second one finding inverse of a non-singular square matrix, and third one solving system of equation. So we have the 3 types of problem: rank and finding A inverse and solving Ax is equal to 0. If you look into this unit 1, so majorly we have these 3 topics, and also if you look into this rank, so rank we have the 2 methods we have by find rank by 2 methods. One is the echelon form, second one is the normal form. So we have the 2 methods for to find the rank of the given matrix by reducing the echelon form and normal form. For coming to the inverse, we have the only one method is there, that is compute the inverse of a non-singular square matrix by using Gauss-Jordan method. Okay. And next, for system of equation, we have the 2 types of the system of equation. The first one is the non-homogeneous system of equation. The second one is the homogeneous system of equation. So non-homogeneous means Ax is equal to B is called non-homogeneous system of equation. Ax is equal to J is called homogeneous system of equation. This is homogeneous. This we can call it as non-homogeneous. So these are the main topics, and subtopics are this one. If you look into the problems, so here we'll get one different type of problem for the finding rank by echelon form, and also finding rank of the matrix by normal form. So this is the second type of different type of question. But if you the Gauss inverse also, we have the only one problem we have. This is one kind of problem we have. This is one kind of problem. If you look into this non-homogeneous system, so we have the total 5 different type of problems we have in the non-homogeneous system. One is the first kind of the problem is no solution problem. The second is the unique solution problem. Third one is the many solution problem. The second is the unique solution. Third one is the many solutions. The fourth one is very, very important. So always asking the examination, you will keep some unknown parameters. Let us say A and B are lambda and mu. For what values of that lambda and mu, the system have no solution and unique solution and many solution. So this is very, very important for exam point of view. So this keeping parameters. Keeping 2 parameters, some let us say lambda and mu. And the last one, you will keep only 1 parameters. You will keep only 1 parameter. Then straight away after for what values of that parameter, the system has a consistent, and for what values of that parameter, the system is inconsistent. So totally, if you look in this non-homogeneous system, so we have the 5 different types of problem. Okay. But coming to the homogeneous system, we have three different types of problem for this homogeneous. So first type is no solution. This is the no solution is always consistent. Only thing whether it is a trivial solution or non-trivial solution. But homogeneous system is always consistent. Only thing we have to find out whether it has a unique solution or many solution. So the first one is what? Unique solution, that is called trivial solution. Second case, we have the problems are many solutions. The third type of problem is it will keep some unknown parameter. So ask for what values of that parameter that has the non-trivial solution. So keeping some parameters, some let us say lambda or some k, you will keep like that. You will keep some lambda and k. For what values of the lambda and k the system has non-trivial solution, we'll ask that one. If you look into totally how many different models type of problem unit 1 into, let us say this is 1, 2, 3, here 5, here 3. So total we have the 1, this is the 2 is the for the rank problem, 1 is the inverse problem, 5 for the Ax is equal to B, and 3 for the homogeneous. So 5 plus 3, 8, 9. So total we have the 11 different concept we have in the unit 1. So definitely for both slow learners and as well as fast learners, you can practice this. Don't skip any topic also. Moreover, it is not involve any calculus part. Only we are playing with the numbers only. So most of the students understand the concept, but they are not getting the right answer. The reason is only for the practice. So they will attempt the problem, but they will get the wrong answer. The reason is only for the calculation error. Then how to resolve that calculation error is only thing is practice. Now we can see in the, for example, if you see any shop, in Kirana shop, you can do in illiteracy also they can do the calculation correctly. They will. Only thing is by practicing will do that one. So my advice is do more number of problems on the rank of the matrix. Definitely your accuracy will be improved. To don't skip any topic from this unit. Okay, after this completion of this all the units wise, then I will come to the what are the expected questions for the examination unit wise. I will cover that one. So next we will go to the unit 2. So unit 2 is eigenvalues and eigenvectors. Eigenvalues and eigenvectors. In that eigenvalues and eigenvectors, so we have the majorly 3 different types of problem in this unit. The first one is Cayley-Hamilton theorem. Cayley-Hamilton theorem. The second one, diagonalization of a matrix. Third one, reduction of quadratic form to canonical form. Quadratic form to canonical form. So these are the mainly 3 concepts we have in the unit 2. The first one is the Cayley-Hamilton theorem. The second one, diagonalization. Third one is the reduction of quadratic form to canonical form. So this all the concept, the key base concept is the finding eigenvalues and eigenvectors. So except this one, the Cayley-Hamilton theorem, the remaining 2 are the connected with the eigenvalues and eigenvector. If the students are perfect in finding eigenvalues and eigenvectors, we can easily score marks from this unit. Okay, in the Cayley-Hamilton theorem, if you look into the Cayley-Hamilton, so we have the 2 types of problems. We have this one. Straight away, first type of problem is what? Just we will ask the question, verify the Cayley-Hamilton theorem. By using Cayley-Hamilton theorem, find inverse and power of a matrix. Like that, some a to the power of 4, a to the power of 5 will ask. So this is very easy question. So everyone can answer also. Particularly this concept is very easy for the slow learners also get the marks from this one. Only thing you need to compute the accurate characteristic equation. Okay. Then sometimes we'll give the matrix expression. Then compute that matrix expression value by using Cayley-Hamilton theorem. This is the second type of problem. The first type of is only the verification problem. The second type is what? By using Cayley-Hamilton theorem, we can compute some matrix polynomial. Coming to the diagonalization, it is a one concept. For this, again, we need eigenvalues and eigenvector. So we have the different procedure in this one. So next is, this is compulsory question. Reduction of quadratic form to canonical form. If the student practice this question, student are perfect this reduction of quadratic form to canonical form. So entire unit 2 will cover in this one. Why? Because in this process, we need to find eigenvalue, we need to find eigenvectors, and we diagonalization, everything will cover in this one. So mainly we have the only one type of problem, reduce the quadratic form to canonical form by orthogonal transformation. So after that, find rank, index, signature, nature. So definitely this is total unit is connected with the concept of the eigenvalues and eigenvectors. So better you, this is also very important for the slow learners also, and both fast and slow learner. But particularly in this also there is no calculus part. Here also we are playing the game with only numbers and matrices only. So that by practicing this one, we can score easily from unit 2. So let's move to the unit 3. So unit 3, so we have the two major topics in the unit 3. The first part we have the mean value theorem. The second part is the functions of several variables. Okay. So in the mean value theorem, we have mainly three named theorem. They are the Rolle's theorem, Lagrange's mean value theorem, Cauchy's mean value theorem. So first one is the Rolle's theorem. The second one is the Lagrange's mean value theorem. Third one is the Cauchy's mean value theorem. So this is the first part of the unit 3. First in this, what are the scope for asking the question for exam point of view? Mainly I am covering this in this video only long answer question. We will discuss separately for the how to answer the short answer questions for this linear algebra and calculus. So coming to the this Rolle's theorem, we have the two types of questions are there. One is applicable, verify the Rolle's theorem, whether the theorem is applicable or not. If all conditions are satisfied, the theorem is applicable, just find C. So first one is applicable. Second one is not applicable problem. If any one condition fails what you have tried, simply the theorem is not applicable. Totally, so we have the two types of problems are there for chances for asking for the Rolle's theorem. Coming to the Lagrange's mean value theorem, here we have some, first one is the applicable application, whether the Lagrange's mean value theorem applicable or not. Same, if all conditions satisfied, then find C. If any one condition fails, not applicable. But again, we have some inequalities are there. Inequalities. We can prove some inequalities by using Lagrange's mean value theorem. So this is very, very important exam point of view. Most of the time is covering the questions from this Lagrange's mean value theorem. Particularly, we can prove the inequality by using Lagrange's mean value theorem. After that also, we will give some particular case also. So we have some 4-5 questions are there. Again, repeatedly they are asking this one. Okay. Then third type of problem in this one, yeah, we can calculate approximately, we can calculate of nth root of any number by using Lagrange's mean value theorem. We can approximately calculate. So mainly we have the three types of problem for the Lagrange's mean value theorem. But coming to the Cauchy's mean value theorem, again we have the two types of problems are there. One is applicable or not. So verification theorem. So next one we have some inequalities are there. Some equalities we can prove by Cauchy's mean value theorem, but most of the time they are asking the verify the Cauchy's mean value theorem. So we have the two types of problem. Mainly we have three standard problems. We have the Cauchy's mean value theorem. So find C value. You will give the two function and verify and find the C value. C values we will get geometrical mean. One will get the geometrical mean. One will get arithmetical mean. So other one mean harmonic mean will get harmonic mean. So these two types of problems are very particularly, these standard problems are very important. If you look into this one, how many problems we have this one? The 2 plus 3, plus 3 plus 2. So total 7 problems for the first part of the unit 3. That is what mean value theorem. So Rolle's theorem, Lagrange's mean value theorem, Cauchy's mean value theorem. Rolle's theorem, we have the applicable problem, verification of Rolle's theorem. Now just we can consider into one type only, this one. So total we have the 6 types of the problems are coming for the unit, first part of the unit. What is the second part? The second part is the functions of several variables. Functions of several variables. First part is the mean value theorem. The second part is the functions of several variables. So majorly in this functions of several variables, we have the 2 concepts are there. One is the Jacobian. The second one, maxima minima. In the Jacobian, straight away you will find the Jacobian, you will give the function and find the Jacobian of the 2 functions of 2 independent variable, 3 functions of 3 independent variable. So directly the compute the partial derivative and plug in the formula, will get the answer. The second type of problems are you will give the 2 or 3 functions, then verify that where they are functionally dependent or not. So the dependent and independent connected with the concept of Jacobian. If the Jacobian 0, that they are the independent. Jacobian not equal 0, independent. Jacobian 0, dependent. So in Jacobian 0 case, you can find out the relation between the given function. So the second problem is functionally dependent. Okay, you will give the functions, find out the relation between that functions, either 2 or 3 function by showing Jacobian 0. So 2 model. Coming to the maxima minima, here for function of 1 variable we have the maxima minima, and function of 2 variable also we have the maxima minima. So function of 1 variable, function of 2 variable, we have the standard procedure is there. For function of 3 variable, again we are converting into 2 variable we are doing, and also we have there Lagrange's method also is there. Lagrange's method. So totally, so we have the in this one also Jacobian is a 2 model type of 2 models, and here also we have the 2 models. Function of 2 variable, maximum minimum, function of 3 variable. So total we have the 4. Then 6 plus 4. So total we have the 10 different types of problems in unit 3. Even if student if can focus in the first part also, so most of the time you can chances are getting for the 100% of mark. But if you prepare half only first half, definitely will get the 50% of marks from this unit. And this from this unit onwards, so slowly the calculus part will be begin in this concept. Okay, even this is also we can read, we can prepare for the both slow learners also, we can read this practice unit 3 also, because only the minimum calculus part is there, not that much of rigor in the calculus part of this one. So here coming to this, the maxima minima, most of the times in the examination is asking the maxima minima for functions of 3 variables. So that we can do that type of problem by converting it to variable we can answer, or so directly we have another method is there, that is Lagrange's method for solving such type of problems. So particularly the rectangular box problem, what is the largest volume that can be inserted in a cuboid. So these type of problems are very, very important for examination point of view. So let's move to the unit 4. Unit 4 is ordinary first order differential equation with its application. The title of the unit is first order differential equation and its application. So we have majorly exact differential equation, then second one non-exact, how to convert non-exact to exact, then linear, then non-linear, and the last one applications. But it is the So many concepts we have in the unit 4 also. If exact directly we have the, by verifying that condition we can exact, then we have the formula will get only one type of problem. But if non-exact case, again we can find the integrating factor, then we will, after multiplying the integrating factor, that non-exact will become exact. So here the one type of problem we have, here we get the four different problems in the non-exact case. Sometimes non-exact, by the rule we have the four rules are given, by rule 1, rule 2, suppose if you take it, four different problems will get. Coming to the linear in y and x, one type of problem or chances are there. Linear in x and y, so here also chances are for the two different models or scope are there for asking the examination. Then non-linear, if you come into the non-linear, generally three types of non-linear we have: type 1, type 2, type 3. So generally if the degree of dependent variable more than 1, also non-linear. If degree of dy by dx more than 1, also non-linear. If the product of dependent variable and its derivative occur, also that is non-linear. So here non-linear type 1, let us say this is type 1, this is type 2, this is type 3. In type 1 also we have the two types of problem, y in y and x and x and y, you'll get two problem. Here also you'll get the two types of problem. This is for, let us say, this type of problem, dy by dx plus y square is equal to x, because of degree of more than y. So second model is y dy by dx type of problem. Because of this one is now, in this also we have the two types of models are there. But coming to the type 3 nonlinear, we have the four types in this one. One is the factorization of p. The second one solvable for x, solvable for y, and clearance equation. So total four different types of problems we have, and moreover it is difficult to understand the most of the student for this one. And just to count it, how many different types of models we have here: 4 plus 2, the 6 plus 2, then 8, then 8 plus 2, then 10, 10 plus 5. So minimum here 15 models for the only the without application only. So application we have the three mainly applications we have, and moreover it is easy also for the understanding. One is the Newton's law of cooling, that is the Newton's law of cooling. Law of natural growth and decay problem. So we have these three named applications. We have this one. So here four different types of problems we have. For cooling, we have the two different types. If temperature is given, we can calculate time. If the time is given, we can calculate temperature. Growth problem one model, and decay also one model. Total we have the four. Then 15 plus 4, total we have the 19 different model problems are there in the unit 4. So any type of question may come in the examination. But after that, I will cover what type of questions are coming, particularly for you can focus for the slow learners. So once I will finish this unit-wise content, we'll move to the discuss that one. Okay. So unit 5. Unit 5 is the higher order differential equation with constant coefficient. So the equations are like this: f of d of y is equal to x. So this is type of equation is called non-homogeneous equation. Okay. F of d of y is equal to 0. This type of equation is called homogeneous equation. Homogeneous differential equation. So the general solution of homogeneous is CF plus PI. That homogeneous only CF. So here what is the common for this both solution for solving non-homogeneous is homogeneous means the complementary function. The students are understand clearly the writing of the complementary function. This is very simple also. We have only for that they need to practice to finding out fruits and understanding the how to write the complementary function for different three cases. Generally it depends on the roots of the auxiliary equation. So mainly we have the three types of the nature of the roots. If real and distinct, how to write; complex numbers, how to write; surds, and how to write. If you practice this type question, definitely we'll get the 2 marks for any question. So we need to find the complementary function. We'll get the 2 marks. For coming to the non-homogeneous, we have some shortcut methods are there depending on the form of the function. So one is what? E to the power of ax, we have the shortcut. Then sine ax and cos ax, we have the shortcut methods are there for finding the pi. So here pi, this appears this right hand side function. So of right hand side 0, only the complementary function is the general solution. So whenever if the non-homogeneous differential equation, so we need to compute both complementary function and particular integral. Complementary function as usual we can compute that one. For coming to the particular integral, we have some shortcut methods. First you can compute by using shortcut method. If at all it is not covered by the shortcut method, we have the general method is there, or another procedure also there. Will explain to you that one also. Will tell you that one. So second short, this is the first shortcut. This second shortcut for this one. Third one is the polynomials. For polynomial also this is shortcut. The fourth one, e to the power of ax into v. So v may be sine or cos and polynomial. The fourth one, x to the power of m into v. Here v may be sine and cos. The sixth one, xv. Here v also sine and cos. So here this is 3, this is the fourth one, this is the fifth one. It's total we have the 6 shortcut methods are there. If any function is given in this one, for example, if the problem is like the d square plus 1 of y is equal to x square is given, e to the power of minus x is given, sin x is given. So you can apply x square is the polynomial shortcut, e power x is this one. Suppose if you given e power x into v, e power x cos x. So whenever this type of functions are given, then we can get particular integral by the shortcut method. Sir, what we do then in the case of if the shortcut method is not covered? For example, if the problem like, suppose if you have the problem like d square plus a square of y is equal to secant ax or tan ax like that. But this is not there in the list of shortcut. In such cases, how to compute the particular integral? So in such cases, either we can go for the general formula for computing the particular integral, or we can use the method of separation of variable. Method of separation of variable. This is also one of the very important, is called method of separation of variable. Separation of variable. Okay, so this is very important exam point of view, method of separation of variable. So whenever that pi is not covered by the list of shortcut method, so better you can solve that problem by method of separation of variable. The last one is Cauchy-Euler equation. Cauchy-Euler equation, or we can call homogeneous equation also. Homogeneous equation. Cauchy-Euler and homogeneous equation. So totally if you look in this one, this is 6 and sometimes the 7, 8, 9, almost 9 different types of problems are there in this one. But for Cauchy-Euler, again the difference between this the first problem and this last one is all these are whatever the discuss are differential equation with the constant coefficient. But Cauchy-Euler equation is the differential equation with the variable coefficient. So that is convert into constant coefficient. You can solve as usual. So your expected question compulsory this method of separation of variable and Cauchy-Euler. Now let's move to, we'll discuss the exam point of view. So in examination, what are the expected questions? What type of questions the probability to come the unit wise I will explain. So generally, so we have the internal, we have the 40 marks. CIE, we have the 40 marks, we have. Then SCE, semester end examination, we have the 60 marks. So this is our distribution of the marks. For SCE, again we have the part A, the 60 mark, the part A. So we have the 10 marks questions. So we have 1 mark questions, all 1 mark questions are there. So A to some J we can say, like will do 10 mark question, each one carries 1 mark. So part B, so we have for each unit you will give the 2 questions. So you have to answer any one question. So internal chances are there. Now we'll discuss what is the probability unit wise, what are the expected questions, what type of questions are covering, what is the probability of asking repeated questions. Okay, so these questions I am going to discuss unit wise. So we'll discuss later the part A. So what are the repeated, what are the scope for the part A short answer question. So we'll prepare the separate video for that one. So first one, part B, we'll move it to. From coming to the unit 1, he will give the question like this: A, B, sometimes A, B, like this he will give. So sometimes this problem may chances are there for rank, find rank. He will give some Ax is equal to B. Here he will ask A inverse. So generally whenever he will ask A inverse, sometimes only he will give the only instead of each one carries 5 marks. 5 marks, 5 marks. Sometimes his inverse is given, some people will give for the 10 marks depending on the size of the matrix. If the 3 by 3 will give the 5, if the 4 by 4 is given, so straight away he will ask the 10 marks. Some he will give the Ax is equal to 0. So this is the depending on the examination setter mood. Okay, some setter will give AB, some setter directly will give only A, only one question will give. So here if you look at that one, the student practice the rank. He is perfect in rank in finding echelon form and normal form. Definitely he will get the 5 marks. And if he practice inverse also, sometimes he may get 5 marks, or even sometimes he may get the 10 marks also. So all concepts are very easily. Don't skip any concept for unit 1. So we have only I think 10 concepts are there for unit 1. So you can easily practice with this one. Only the practice is required. Don't skip any concept from the unit 1. Because it is no calculus part is there. So particularly the slow learners. So this is the very good for getting the marks from this unit 1. So we can easily score from 10 marks from this unit 1. Okay. Only first compulsory find the rank, you can practice and inverse, definitely will get the marks. And also Ax is equal to B and Ax is equal to 0, all are again connected with the concept of rank only. Okay. Then so this is the easy we can get the slow learners. We can by practicing the rank and finding A inverse and Ax is equal to B, will get easily 10 marks. Okay. Coming to the unit 2. Unit 2 is completely connected with the eigenvalues and eigenvectors. If you perfect in computing eigenvalues and eigenvectors, we can easily score 10 marks from this unit 2. And particularly questions will ask like AB, or AB. Or sometimes you will ask that only AB or only just one question A also will ask. If this case 5, 5, 5, 5, if you ask 10 marks also. Here sometimes what they just, sometimes only simply will ask like this also only A or B. A or B, only one question only will ask you. Suppose what are the possibilities are there for asking A, B. Suppose you asking for only A means compulsory will give the Cayley-Hamilton theorem. If you ask only one question from the unit 2, either Cayley-Hamilton theorem or eigenvalue, eigenvector or reduction of quadratic form to canonical form. So very simple, this Cayley-Hamilton theorem. Only thing, just you have the patience to compute the characteristic equation and systematically calculate the A square and A cube, whatever the powers you require, and substituting and show that we can easily get the marks by practicing the Cayley-Hamilton theorem. Cayley-Hamilton theorem, and also in that we have the only 4 or 5 problems are there by Cayley-Hamilton theorem, we have computed that matrix polynomial value. I think we have, hardly 4 to 5, 6 problems are repeatedly asking this one. So what is the other chances, next chances, other question probability is, the other question is either eigenvalue and eigenvectors compute, or they can ask the reduce the quadratic form to canonical form. Reduce the quadratic form to canonical form. Reduce the quadratic form to canonical form. The student answer this type of question, practice this type of question, quadratic form to canonical form. So entirely total unit 2 is covered in this one. Why? Because in this process, we need to compute eigenvalues, we need to compute eigenvectors, and also diagonalization also. Only we have the three major concepts. One is the Cayley-Hamilton theorem, diagonalization, reduction of quadratic form to canonical form. I think better you practice Cayley-Hamilton theorem, reduction of quadratic form to canonical form. I think we have the 6 or 7 problems are there. Reduction of quadratic form to canonical form. If you practice that problems, most of the times that problems are repeated. The problems are again and again and repeating that problem. So only thing we have to, only the practice is required, that one. So in that, everything will cover: eigenvalue, eigenvector, diagonalization. Even if asked for diagonalization also in this cover. So it is very small unit also. We can easily score. Only thing for this one, you have to get the correctly eigenvalues and eigenvectors. Most of the people will do, but they will get the wrong values. So my sincere advice is, after getting the eigenvalues, you can check it. We have the conditions are there. The sum should be equal to the trace. The product should be equal to the determinant of the matrix. After verifying this only, you can go for the computing eigenvectors. So we already evaluated, but most of the students, we are failing finding the eigenvectors. Some students are getting wrong eigenvalues. Even if you get one eigenvalue, if you get the wrong, if you proceed everything further also, but everything will get the wrong answers. You will get some, depending on the calculator, will give the 60% or 40% mark will allot. So better don't do any single mistake in the computing eigenvalues and eigenvector. So it is scoring unit for the slow learners, this unit 1 and unit 2. Unit 1, unit 2, better you can practice, 100% practice unit 1 and unit 2. You will get 20 marks easily. You can score from this first 2 units. Okay. The coming to the next unit 3. Unit 3 also A, B. Sometimes you will have A, B, or sometimes only A or B will ask like this. If sir A and B asks for the post is given like this, A and B, the first format. So the chances are there, even if you prepare perfectly the first part of unit 3, that is the mean value theorem, also you can get the marks. Sometimes will give some setter will give the from half part A, B will give another half part will give the A, B. But only few setters will give one part, one A from the first part, B from the second part. So depends on the setter that will be coming. But if you prepare first half also, definitely will get the minimum 5 marks. Minimum 5 marks. So you can, those who are feel difficult calculation part, the calculus, because of calculus start from the mainly for the second concept. Even first concept, mean value theorem also, only the basic level calculus are involving. We can easily prepare the mean value theorems. We can easily prepare the mean value theorem. We can easily get the 5 marks. We can easily get the 5 marks. If sometimes if one question is given, you may get 10 marks also. So depends on that is the question paper. Okay. And from part B, my suggestion is, just to practice the important questions, not all. But part 1, you have to practice all. Only we have the mainly 3 theorems: Rolle's, Lagrange's, Cauchy's mean value theorem. You can practice, don't skip any concept in this one, any model. But coming to the part B, in the second part of the unit 3, you can practice the expected questions only. So some Jacobian problems are repeated questions, you can look into that one. And some problems are the maxima, minima related to the rectangular box, greatest solid that can be inserted in a cuboid or something. That type of problems are selected, you can read it. Definitely we can get 5 to 10 marks from this one. If you prepare well, 10 also, or worst case will get the 5 marks. So slow learners compulsory, you can don't skip any concept. Unit 1, unit 2, unit 3 also, if second part also you can score, but the calculus part is there. So minimum 5 marks you can score it. Okay. For coming to the unit 4. So unit 4, we have the only solving the first order differential equation and application. Here so many different kinds of the models are there in unit 4. It is difficult to practice all the questions, all kinds of questions for the slow learners. My suggestion is, from this unit, better you can prepare these applications. Applications, we have the only 4 models are there. 3 application in that 4 different models are there. The same type of logic we are applying for this one. All whatever the 3 applications are, the same logic we are following in that 4 different models we have. And also everyone can easily understand, no calculus part is there, only simple basic understanding the concept and plug in the values will get the answer. And my advice is, we have almost 10 questions are there, 10 to questions are there, they are repeating the same concept again and again. If you you can start with the slow learners, don't prepare all first you can prepare this application, will get 5 marks, will get 5 marks. If you have time, you can understand, selected you can prepare for exact and linear. But slow learners compulsory, you can prepare this one application. So definitely you will get, here also chances are A, B or A, B. Suppose if this type of pattern, what are the possibility? Sir, A, B, sometimes A only will come up. Here also if come this one, here suppose exact problem is there, compulsory will give the application will give something. Here non-linear will give. Here also non-linear will give. Linear like that. Here also some non-linear sub will give. Here linear will give. Sir, application will give. So definitely any one question, the more chances are there for coming for the application part. So if you thorough the application part, so minimum guarantee of the scoring 5 marks. So don't skip for the slow learners. I'm focusing on the slow learners. For 5 marks, we'll get this one. So unit 3, let us take the 5 marks. Unit 4 also, we have the 5 marks on it. Okay. Unit 5. Unit 5 also, we have the majorly solving the differential equation of higher order. So here the questions are, suppose AB and OR A and B. Here sometimes AB and OR A. Here some f of d of y, some shortcut methods we are covering, some x square sin x, non-homogeneous. So compulsory one question, method of variation of parameter or Cauchy-Euler. So one question come method of variation of Cauchy-Euler, other question is from remaining part. Even if you perfect also, method of variation of parameters means whenever generally the problems of type d square plus a square is equal to secant a square, d square plus 3d plus 2 of y is equal to e power ax. So all these type of problems are not covered for the particular integral for the shortcut method. So compulsory will go for the method of variation. So compulsory one question, method of variation and Cauchy-Euler equation. So other question, the chances are there for the remaining part of the syllabus. So even if you perfect in method of variation and Cauchy-Euler also, definitely you will get the 10 marks. But my suggestion for the slow learners, so this is depends on the question, you may answer or not. But for any question, so we need to compute the complementary function. That complementary function is very simple. By practicing 1 hour, we can easily perfect for computing the complementary function. Only that depends on the roots. Once you get the finding the roots, by nature of the roots, we can easily write the complementary function, so that we can get 10 marks. We can easily go depending on the problem. 10 marks we can easily get. Or better, you can practice the method of variation of parameter. Only the selected problem, 6-7 problems are there. Better you can practice that method of only for the slow learner. Now just I will summarize this one. From unit 1, the slow learners will get 10 marks because very simple. The unit 2 also will get the 10 marks because of the eigenvalues and eigenvectors. But unit 5, let us take only 5 marks, we can add it. Unit 4, 5 marks. If you answer complete, preparing off also will get 5 marks. Unit 4, pakka question, that is the 100% we can, the chances are there for the application for 5 marks. Then just worst case, I am taking the 2 marks for the CF. This is for CF for the 5th unit. This is for the application. This is for the Rolle's theorem. Now just you can add it 32 marks for the minimum you will get the from out of 60. But again, we'll make one more video for how to get that part A marks. So part A we have the 10 marks. Then how to get the minimum 6 to 10 marks. First case you will get the 6 marks because of in the 10 marks also 5 marks they are asking the theory question, the 5 marks they are asking the problematic questions. So I will prepare one video for that short answer question. So definitely that will help you. But today's lectures mainly I focus what are the units we have, what are the main questions or possibilities for coming the questions for the unit wise, and what type of questions you have to concentrate for the slow learners for the get the minimum marks. Only my advice, again and again I'm repeating, unit 1, unit 2 compulsory, don't skip any topic from the unit 1, unit 2. From 3 you can select it, you can take it as the first part and second part. From 4 5 the selected topics which are not involving the more calculus rigor, just like the unit 4 is application, and unit 5 the complementary function. There is no involve any finding complementary function, only the simple logic we have that one. So if you practice this, you can concentrate on this one, definitely the students can get the minimum mark, as well as the fast learners also. What are the different types of models I discussed? If you focus on that one, at least you can solve one problem for the different kinds of the problem. If any question will come, definitely it will be any one of that model. So hope after watching this video, you can recap the every concept of the linear algebra and calculus. So definitely it will help you for the to get the good marks for the linear algebra and calculus. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.